previously I looked at the geometric series, and we say that a geometric series is one whereby the terms in that series have a common ratio, and we say that for it to converge, it's the magnitude of its common ratio. See? For it to converge, it should be less than 1, and for it to diverge, should be greater than or equal to 1. So that was the main thing that we covered. Then today we're going to look at the alternating series. So basically, an alternating series is one whereby the terms interchange between positive and negative terms or signs. Let's take an example. Yeah, let's say 1, -2, 3, -4, 5, -6. You realize that there's a pattern between consecutive terms, between positive and negative. So usually there's a general formula, say, a general expression of an alternating series, and you say it is summation from n, let's say from 1 to infinity. Since we said we're looking at infinite series of it's negative 1 into n minus 1 times b n, yeah? So this is -1. Here is where the pattern, the positive and negative pattern comes about, and the -1 to power a certain value. And yeah, let's look at an example from n is equal to 1 to n is equal to infinity. Yeah, so here is a -1 to power n. It doesn't matter whether it's -1 or so 3n minus 1 over 2n plus 1. Yeah, so here, we're going to look at how this series behaves. So we first get, let me say, the first 3 terms. So we're going to substitute, let me say, from n is equal to 1. This is 2 over 3. So 2 is, let's say, 3 times 2 is 6 minus 1. It's 5 over 2 times 1 over 8. Sorry, 2 times 1 over. This is 5 over 3, then say the third. It's 9 minus 1, 8 over 2n plus 1. 6 minus 1, 8 over 7. So it's a bit difficult to determine whether it converges or diverges. However, it went in one part, the multiplying of this -1. So -1 to power 1, -1 to power 2, and then -1 to power 3. So here, the first term of the series will be to power 1. It remains a negative. Yeah? It's -2 over 3. The second term is to power 2. It's an even power, so it takes the positive value. And then the third, it's an odd power, so it is -8 over 7. So let's say plus 5 over 3 plus -8 over 7. Assuming they want us to find the convergence of they want us to determine whether this series converges or diverges. What do we normally look at? we tend to find like the absolute, we take the absolute value, okay. Let me say we take the absolute value of every term, and then we determine whether it converges or diverges. So what determines like the absolute term? We tend to isolate or ignore the what? The part where we are squaring or finding powers, yeah? So if we are to relate like the general expression with the series that we have, we notice that the Bn is equal to the fraction plus 1. So to find the limit or the value at which we are, or what? The value at which converges or diverges, we tend to, we say as n tends to infinity, L approaches, let me say a value, let me say any unknown, let me say it approaches x, yeah? So we simplify this function, let me say multiply both the what? The denominator and the numerator by n, by 1 over n, sorry. And then this is 3 minus 1 over n over 2 plus 1 over n. Then we say as n is tending to infinity, 1 over n, okay, is also tending to 0. That makes sense? Yeah? So it'd be like it's 3 over 2. This is the value of the limit. Sorry. 1 over n. Let's say it's 1 over infinity. It approximates to 0. Yeah. Which other concept do I have to cover? So, okay, let me say in summary. So, in summary, the alternating series diverges if the sequence, let me say the sequence of the absolute values of the partial sums diverges and vice versa. Okay. So another thing that I want to cover is the divergence test. You figure that most of the methods that we look at tend to either finding convergence or finding the value at which you are converging. They don't really classify if it's diverging or not. So usually if you don't know the type of series that you're dealing with, and maybe they've asked you to find if it converges, and probably don't know the technique that you use, you start with a divergence test. And it states that if, let's say, the limit as n is approaching infinity, n is the number of terms, and so this is the function, is not equal to 0, then the series diverges. Okay? So A of n is basically like the function that represents the series. So let's look at a few examples. So summation from n is equal to 0 to infinity. If we say 5n plus 3 over 7n minus 4. So basically what you do is just substitute. Okay, you first simplify and then you substitute. Now here, simplifying would multiply the denominator and numerator by 1 over n. So it was 1 over n. This is 5 plus 3 over n over 7 minus 4 over n. So if this doesn't equate to 0 when you substitute for n is equal to infinity, you shall conclude that it diverges. Yeah? So 5 plus 3 over infinity, let's say, n and 7 minus 4, so this approximates to 5 over 7, which isn't equal to 0, so this series diverges. Yeah, then let's look at one that may actually give us a value that, series converges, since it's not equal to 0. Yeah. So we can look at one that actually equates to 0. Let me say the summation from n is equal to 0 to infinity. Let me say 1 over n squared. Yeah, so the a of n here is equal to 1 over n squared. So as n is tending to infinity, then a of n, which we take as the limit, is equal to 1 over infinity squared. Yeah, so this is equal to, okay, it approximates to 0. So now this one is equal to 0. So this one, this divergence test doesn't confirm that it does what? Converge or diverge. Okay, it's just a way of checking if if a series diverges. However, if it doesn't diverge, doesn't prove that it converges, you should find another, let me say, technique of finding the point of convergence, if that makes sense. Yeah.